Unit rate is slope. So in science, you guys have been doing some stuff with unit rates and finding your rate of change. You're going to be using a graph, a table, and an equation to determine our unit rate, or often going to be referred to as our slope, or proportional reasoning, what we're talking about. And we're going to have to distinguish between what's linear and what's nonlinear as we get through this unit. So, is there a relationship if you think of your age since birth and your height? And let's just go from age from birth till you are about 5 years old. Do you think there's a relationship that as you age, your height changes?
Yeah.
From when you were born. What would you say that relationship is? Is it increasing?
Increasing.
It is increasing. I agree. So if we are thinking of as your age increases, right? So we are going to write this as our age increases, and we are talking about probably in years, and we're going from 0 to 5 years. Please write, some of you that aren't writing. What also happens is that we notice that our height also increases, right? For most people, usually up to a point in time, right? And then it might level off, and then it might continue, you might continue to grow, and then it might level off for a while and continue to grow, okay? So then we are looking at that. So it says, can we display this relationship? So if I wanted to think about this graph, and I have time, and we're talking about time in years, and we're talking about our height. And our height here we might have in inches, possibly. It might start off something like this, right? In that first year we grow quite a bit, we continue growing, and then there might be a period of time when it might level off, right? And it might continue growing. And we could go something like that, right? Where you're going to continue to grow, and it might level off for a period of time. Maybe for a year you were like the same height, and then all of a sudden, you know, they measured you, went to the doctor's office, and oh my gosh, this kid is growing, right? That's one way of displaying it, would be a graph, okay? So if we are looking at it, one way of displaying is definitely if we are looking at a graph. Anyone think of a different way of displaying this? If we are looking, that's another way that we could display this. And it's kind of in the I can statements, you might see it. Another way of displaying it would be a what?
Timeline.
Could do a timeline. But if we are looking at this, we might be thinking besides a timeline, what was one of the words used up in the I can statements? Well, we have the graph. That's here. We could also have a table, right? If we wanted to show this in a table, we might say our age, and then we might have our height. So you could have a table this way where you put your ages down, and you might have half a year, right? Then you would have 1 year, and then you might have when you're 2 years old. That table, so drawing this on yours, we could have our table also going this way where we have age and height written this way. What was the last in the I can statement besides a graph and a table that it says we should be able to look at?
Variable.
Look at the I can statement and the last one that you have in your notes, and it is to table, graph, and equation is that last word that we are looking at. And so we can display it usually in all three of these ways. These two are much more visual, whereas a lot of times our equation is not going to be as much. So if you would continue reading, Johannes, you read.
In order to model a relationship, we first need to identify the variables. First, independent variables. Bar line, input, and bar line. The cause variable. Dependent variable.
Just output.
Output. The effect variable.
So when we are looking at our independent, when you guys have been working in science, your independent is always your x variable. Your y is your dependent variable. The cause variable, if we are thinking about it, this is our independent. This is usually on our x-axis, so please write this. It is usually time when we do our equations, but it might not always be time. But if you're comparing something with time, time is usually going to be your independent variable. That might be your hours, it might be your days, it might be minutes, it might be seconds. So any of those are a lot of times going to be our independent variable. Our dependent variable is our y-axis. That is usually, the y-axis is our vertical axis that we are looking at. So that is the effect variable. In this case, that would have been our age, or our height, right? If we are looking at the situation, we're looking at our time, how old we are, and we're looking at our height. So x is independent, y is dependent. It says the independent variable is modeled by usually the variable x, and our dependent variable is going to be modeled by our variable y. So the first question we want to take a look at is, how do we make a table of values? So when we are looking at our tables, one of the first things we want to put down is that when we have a table of values, usually we're going to have our two variables and we're going to set it up, and it's either going to be in rows or it's going to be in columns, and I'm going to show you both ways. Most of the time in our homework, a lot of times, so rows is when it goes across. That would be something like we have x and we have y, and we put the numbers behind. So we have 0, 1, 2, maybe 3. We have 0, we have 14, we have 28, okay? And we continue with our numbers, so filling those in. The other way that we sometimes will see our table is that we will have columns. So when you're thinking of a column, columns are what go up and down. So columns are going to be more like this, where we have an x and a y. The ones as we start our homework tonight, a lot of times I'm going to have you make your tables this way. So again, you might have 0, 1, 2, 3, and we might have it 0 and 0, and then we had 7, 14, and 21. So just looking at some different values. So our table is usually going to have numbers within the boxes. Okay, so you're going to have your numbers written in the boxes. Usually you get to choose the x. It's independent. But a lot of times we pick numbers like 0, 1, 2, 3, 4, 5 because they're easy numbers to compute. You could pick fractions or decimals, but usually those are going to be our easiest ones. When we look at a graph, what we are looking at is we are looking at points that we are going to, points plotted on a coordinate grid. When we plot our points on a coordinate grid, that is this y and x, that's our coordinate grid that we are talking about, okay? When you plot points, you usually have an x coordinate and a y coordinate. The x coordinate is telling us how to move left and right, that first number. If it's positive, you move to the right. If it's negative, you move to the left. The y coordinate is going to tell us how to move on that coordinate grid up and down. So again, if the y is positive, you'd move up, and if it's negative, you'd move down. And when you start graphing, you are always starting at your origin, which is located at 0, 0. So we're always going to label our y and x axis. Sometimes our graphs are only going to be in this first quadrant, it's called, quadrant 1. But if I was going to graph the points over here, I would have had like 1, 7 would be like at this point. What did I do? I went over 1 and up 7. If I was going to plot 2, 14, that means I go over 2 units and I would go up 14 units. So that point 2, 14 would be something like this. And then usually we are going to take our points and we are going to connect them with a line. So then usually our final answer is going to be something like this, where we're going to have that line, okay? So that's what a coordinate grid, or if we're plotting on a graph. When we write our equation, what's an equation? We have been doing equations. It's a formula with more than 2 variables. What did we call that in our last unit? Variables or equations with more than 2 variables. We did it at the end, 14 and 15. They were called what kind of equations? Anyone remembering? Literal equations. So We're going to look at literal equations. What's a literal equation? It's just an equation that has more than two variables. So literal equations, and ours are almost always going to have two variables, and the two variables that we are going to be working with are going to be x and y. And when we write that equation, a lot of times it's going to be y, which we said was which variable, independent or dependent. That's our independent variable, right? Independent variable will be equal to, that's why I had that 13c where I was so concerned that you'd be able to do that, because it's always going to be y equals, and we are going to have what's called our unit rate, so it might be something like 2 times x, and this is going to be our unit rate that we're going to talk about, or our rate of change, unit rate, and then it's going to be times x, which is our dependent variable. Okay, so it's usually the independent variable is equal to our unit rate, or our rate of change, times our dependent variable. Okay, there's going to be many different forms of this equation, but that's kind of the most general form. Sometimes that rate of change might be 1. Sometimes it might be a half. Sometimes it might be a negative number when we look at those. Okay? So we're going to start off on that next page. Hunter, would you please read what it says?
This year, what?
Where it starts with this year.
This year, scientists predict that the first snow of the year will fall at a rate of a ½ inch per hour. They also can predict that it will snow for 12 hours.
Jeffrey, did you hear what it said? Will you read it again then, please? This year? No, Jeffrey, go ahead. This year, we're on that next page of your notes.
Scientists predict that the first snow of the year will fall at a rate of a ½ inch per hour. They also can predict that it will snow for 12 hours.
So what we're going to do in the next couple pages in your notes, we're going to make a table, we're going to make a graph, and we're going to write an equation that's going to model this relationship. First thing we need to do, and you're going to be asked in your homework, what's our independent variable? Independent variable, we said almost always, y is our time. Independent is always our, just the opposite, x. Independent is our x. That's going to be our time. In this case, we would be talking about our hours, right?
Oh, yeah, you did. You're right.
Okay. So x independent is our hours. Yes, that is going to be when we make our graph, that's on the x-axis, that's going this way, horizontally. Our dependent variable is our y. That is, in this case, the snowfall, right? We've already had our first snowfall, but this one is measured in, if we are talking about our snowfall, in inches. Okay? And then it says, what's the explanation for why we know independent and dependent variable? So, when we look at this, what we are looking at is that the amount of snow depends, okay, so you want to write this down. The amount of snow depends on the number of hours that it has been snowing. So think, after an hour, we have how much? A half.
No, yeah.
After 2 hours,
An
we have
inch.
an inch, right? If I just measure at 3 hours, I should be able to tell how much, so time is independent. You get to control when you're measuring it, right? So that's why the snowfall is our dependent variable, okay? So, some of you didn't have that down yet, the explanation. I'll wait for you to write, so put that aside, please, and fill in your notes. There you go. The amount of snow depends on the number of hours it has been snowing. Okay? So you're going to look down at that next part. And Connor, would you read as we go down to the next part where it says modeling the table?
Model this relationship with the table. We need to know the rate that snow is falling. What is the unit rate? What is the starting point?
So when we are taking a look at our unit rate, that means how much snow is it coming down each hour? And in our case, it is coming down at what?
Half an inch.
Half an inch. I don't care if you write half an inch with a fraction, or if you put 0.5 inch per hour. Now, sometimes you will see people put, instead of just per hour, they will write in and say per 1 hour. Does it matter if you have a 1 in front of the hour? Most people, if you would say it's gonna snow a ½ inch per hour, they know it's per 1 hour, okay? What is our starting point? Well, at 0 hours, right? So it's the ordered pair 0, we have 0 inches of snow. So here we know 0, x is going to be our hours, and our y is going to be our snow in inches. So, starting at the table, please fill it in with what we know that our rate is. After 1, we said, probably easier to use a decimal, 0.5. Then at 2 hours, you're going to fill in 2, you should be up to 1, right? And again, if you want to use fractions, it's okay if you have 1½ instead of 1.5. Right? Either way, same thing. The question then says, can you pick other points than 0 to 5?
Yes.
So if we wanted to find out at ½ an hour, how much snow would you have at ½ an hour? 0.25 inches, right? How about if I wanted to find at 3½ hours?
It would be 1.
We have 1 point. Does that make sense to everyone? Can we stop and measure time at 3½ hours?
Yeah.
Could I measure 2 hours and 15 minutes or 2 hours and 10, right? I can stop and go, oh, it's 2 hours and 10 minutes from when it started. I can go out and measure it. So we could have a fraction or decimal in here, right? We just didn't. Because a lot of times it's nice to use just these nice whole numbers. And have you sharpen back there, right up in front. Right, pencil sharpener, because I don't want the noise. Okay? And it says, how high can this one go? How many hours did they say it's snowing for?
5 or 12.
So how high can this graph go?
12.
Only 12 hours, which is going to give us 6 inches of snow, right? So if I was looking at this table, I could actually extend this table. 6, 7, these dots are telling me the numbers, but I have to stop at 12, right? And the reason we're stopping at 12 is because the story said
12 hours.
it's only snowing for the first 12 hours, right? If it wouldn't have said it's going to stop snowing, then we could have continued that. So what we need to take a look at now is we are now going to model the same situation on the graph at the top. So on the graph, as we are looking at it, we want to put on our x-axis, what did we say our x was? Our
Time.
variable, that's our time.
Time.
So we're going to have time, and this is going to be in hours. So this is going to be 1 hour, 2, 3, 4. I don't have to put 13 hours, right? Because 12 is where we're stopping. And if we are going up, this is going to be our snowfall. And we're talking in inches. So I might have a half in this first one, 0.5. And then I'm going to have 1. Now, for some of you, it gets really crowded because you make your numbers large. So maybe you don't put down 1.5. You just skip that next line. And then you put, oh, this is going to be 2. This is going to be 2.5. This will be 3. 3.5, 4, 5, 6. We know that this mark in between here is 1.5. We know that this is 2.5, right? We're just not going to write every number. If it helps you to write every number, write every number, okay? So now we want to go back, and it says each row in our table is the same as an ordered pair. So our first numbers in our table were 0, 0. So I start at 0, 0. The next one was located at 1 on my table to 0.5. That means I'm going to go over 1, and I'm going to go up to 1/2. The next one I'm going to graph is at 2, 1. So please plot all those points to what is our stop point? So if we are doing it, our stop point has to be, what number did we say? Up to 6 inches, right? So at 6 inches, we were looking, and we have to have for 12 hours, right? So all along here, if we are looking at those, it's kind of that same constant rate of change. And we are gonna draw a line with that. So a lot of times in this unit, straight edges are a wonderful thing because we want nice, accurate, straight lines. So please plot those points. Starting at 0, 1, 1/2, 2, 1, 3, 1.5, 4, 2, and you're going to keep going up so that you have points all the way along here. And then take maybe the edge of your notebook or your workbook and draw that line. And the question says, after we draw the line through all our points that are plotted, where does the line start? So our start point was at 0, 0, the origin. The stop point is, ours does have a stop point. It's at 12, right, hours, because that's only how long it was snowing, and it was 6 inches. It says, does it need an arrow to show that it keeps going? No. It doesn't keep going, right? The snowfall ended at 12 hours, so no arrow. Whereas tonight, your homework, a lot of times you are going to put an arrow. We've already labeled the axes. If you didn't label your axes, make sure you do that. What would you put for a title of our graph? Connect it with a line. Okay. Cassie, what do you think?
Inches of snowfall?
Inches of snowfall, or snowfall total, so snowfall over time, right? Something like that, okay? So looking at something like that if we were looking at this, okay? So, we now want to write an equation. So as we are writing equations, this is what I want. It says to write an equation or formula for this situation, you need to think about it in words first. So a lot of times I'll ask you to write something in words. We want to fill in your blanks in your notes, which say the amount of snowfall equals, and we should have the snowfall rate times the hours plus the starting amount. So the snowfall amount, remember that was which variable, x or y, snowfall amount.
That was
That
Y.
was our y, that's our dependent. It says it is going to be equal to the snowfall rate, that's our unit rate, our rate of change, equals that, and then these are our operations, times and the plus. So it says after we've set it up in words, we must translate the formula by replacing the words with variables and numbers. So we said our snowfall rate on our graph, that was our y going up and down, so we're going to have y, equals, how much was it snowing per hour?
1/2.
1/2, 0.5, so I'd take either y equals 0.5, or I'd use this one, 1/2. And then it's times, what were hours on our graph?
12.
No. That was our variable x, that was our independent variable. And then it said plus, where was our starting point? 0. Okay. Now a lot of times you will see this written as just 1/2 x without the plus 0. It's understood, again, that if there's nothing back here plus 0, that would be added. So it says, look at the parts that we wrote, think about what each variable means. So, and number. Y is the what? Snow fall in inches, right? The 1/2, that is our unit rate. So when we talk about unit rate, that was when we were looking at it 1/2 inch per hour. And the x in this case, the x was our time, and it was always in our hours when we were looking at this. Okay.
Are we done with notes?
One more page of notes. So, as you take a look at that last page in your notes before we look at your workbook.
We do graphing like past.
So, on your graph, when you turn for Francisco to look at the amount of dollars, in the notes, there really aren't any numbers. So I need you to write down these numbers. This first dash down here is gonna be 10, 20, 30, 40, 50, 60, 70, okay? And if you get up to 80, that's gonna be great, okay? So write those numbers in, because the numbers didn't show up in the workbook. I don't know why. I think when they printed, like mine, they're printed really weird and small, so. And what you're asked to do is we are trying to look at each of our 3 people. And I know it says this is how much they are earning, so the amount of dollars, but we are kind of thinking of that they are trying to save these amounts that they're getting. So first off, where does this ordered pair look to be? How many weeks?
5, no, 4, 3.
So 3 weeks,
60.
and 60 is our dollars, right? If you know that you made $60 in 3 weeks, can you figure out how much money you made in 1 week? What would you do? 60 divided by 3, right? This might be your savings for some of you, right? So how much are they saving? Is he saving per week or work making? $20
Hey.
per week. Quit, please. Next person. Please tell your shoulder partner for the next 2 people how much per much. In his, if he makes $2 a day, right? $2 a day, he's gonna have $14 in a week, correct? Okay? If each day he's able to save 2. It looks like Shauna in a week had how much? 15. Does it keep going up by 15? So 15 each week. So we are now answering the questions. Please write down the 2 names. Who was saving the most money? Who was saving the least money? Okay? Write those 2 down in your notes. We should have had, the person saving the most was Francisco, right? Francisco made the most at $20 or saving the most. He made the most or saved the most at $20 a week, right? Making the least or saving the least would be James, right? Okay? 14 is less than 15. He's not saving as much, right? Okay? So, your homework tonight. If you would please turn to your workbook. Like I said, you do not want to throw these old notes and workbooks. You want to make sure you keep your notes. And I want you to look at problem 1. So I'm going to give you a few hints on your homework. This is not due till Monday. Tonight, your main goal is go back over your notes, study, prepare for that test, practice, be ready. We are graphing this ordered pair, -2, -4 on number 1. What you need to do is start at the origin 0, 0, and the -2 tells us to move in which direction. So above this, please put these arrows to help you decide how to graph. So if it's the x coordinate, what would you tell us, Timothy? How do we need to move for -2 if we start at the origin?
From left to right.
Okay, so if I have -2, I'm going to start at 0, 0 and go where? 2 to the left, right? This -2 says move 2 to the left. I don't put a point there. And then I do what? Because the second point is -4.
Go down 4.
Down 4. So I'm going to go 2 to the left and down 4. And I'm going to put a point there. Okay? So I'm now graphing that next point, Dallas. -1, -2 tells me to do what? Starting at the origin, how do I plot -1, -2?
You go left.
Left 1, and then -2 tells us to go down 2. I'm going to put a point. 0, 0 is nice. It's right at the origin. I am now getting to the point 1, 2. Janessa, how do I graph 1, 2?
To the left one?
to the left one, same as I did for negative one.
Yeah.
Okay, so when you think up here on this, and I'm looking at this, negatives go to the left, positive goes to the right, positive goes up, and negative goes down. So let's start again. If I'm looking at this ordered pair 1, 2, which direction?
Oh, to the right
To the right 1
then. And up 2.
and up 2. And if I'm doing that last one, what am I doing, Haley?
Go to the right 2 and then up 4.
And I am now going to connect these, so using your notes or a straight edge, and put a line with arrows, please. So you want to extend it past the point. It's not a segment, it's a line. And what you are now asked is to fill this part in. So each one of these, like this one, they give you the graph. I want you to put down these points on this graph. And this one is going to be right up here. There's going to be one more. So it then says, make a tape from the table, make the graph. And now from the graph and the table, we want to answer this question. As the x values increase by 1, the y values, so what's happening? As these get bigger, they are increasing. Please tell your shoulder partner how much they're increasing by. Okay? The y increases by how much each time? And what you're really thinking about is, what are you adding? Right? What are you adding from 1 to get to the next one? What are we adding? And each time it should be 2, so we put over here a 2. So when you do the last 2 questions here in your homework, what we are looking at is you need to fill the table in from this graph. And then you're going to answer this question. This one, I tell you that as x increases by 1, this one decreases by 2. And I tell you that you definitely have this point at 0, 0. Okay? So you're going to finish that one. Please turn to the next page and let's look at number 4. Addie, would you do me a favor and read question 4?
Eric's video shack charges $1
Okay, quiet.
to rent the video games for a night. Mr. Addison's Entertainment opens a new store in town, charging $1 per night for a game, and starts to take customers away from Eric's video shack.
So this is back in the day when you actually went to video stores and rented videos instead of doing everything online or on your phone or through some other device. So we have Eric's and we have Mr. Addison's, right? And you want to set up a table like this, and you want to assume that they're going to rent up to 4 videos. If you want to do more than that, they have up to 12. I don't know that you need to go up to 12. So we're going to go 0, 1, 2, 3, and 4. So I need a table for both of them. Can you tell from reading the question, at 0, do they charge any money?
No.
No startup fee, right? So like when I purchase Netflix, I have to pay so much a month no matter if I watch anything or not, right? I'm paying up front back. So this is 0 for 0, then you're going to put in your amounts. You are going to graph both of these 2 tables on this graph in number 5, and it says use a solid line for Eric's and use a dashed line or dotted line for Mr. Addison's. The next 2 are writing equations. This is not due until Monday.